Hello, I want to talk about something very important in modern cloud engineering. How we move from running Terraform locally on your laptops to building a production-grade enterprise infrastructure workflow. Many engineers know how to write Terraform files, but writing TF files is not the same as designing secure infrastructure. This project is about changing our mindset. We are no longer just Terraform user. We must start thinking like cloud architects. A cloud architect thinking about governance, security, isolation, automation, auditability, and scalability. In small projects, running Terraform applied from your laptop may work, but in real companies with multiple team environments, compliance requirements, that abroad become risky. So today I will show you how to integrate Terraform into a CI/CD pipeline, how to use multi-account strategies, and how to design infrastructure workflows that are safe, scalable, and enterprise ready. This is not just about tools. It is about building infrastructure the right way. Business context. Let's start with a real business scenario. Imagine a company that has a dev environment, a product environment, multiple developers working at the same time. Now the company has some important requirements. No one should suddenly deploy to production. No one should run manual change in production. All change must be reviewed. Every change must be traceable. Security policies must be enforced. This is very common when a company grows. At the beginning, maybe one engineer manages infrastructure, but when the team grows, with grows, if 5 developers can own one Terraform apply directly, sooner or later someone will deploy to the wrong environment, or delete critical resources, or bypass review. The key question becomes, how do we operate the Terraform safely in an enterprise? Not just how do we write a Terraform, but how do we control it? That is the problem this architecture is solving. Problem with personal style Terraform. Now let's look at what I call a personal style Terraform. This is very common. Developer clone the repo, run Terraform plan, run Terraform apply directly use there are AWS credentials. What is wrong this way and with it? What's wrong with this? First, no peer review. Second, no separation between that and product accounts. Third, web IAM control. Fourth, no automated policy validations. And most importantly, no audit trail. If something breaks, we ask who changed it, when, and why. If infrastructure is managed manually, we lose traceability. And infrastructure is not like application code. If you deploy wrong code, maybe you restart containers. If you delete a production database, that is a different story. This model does not scale. It works for small experiments, but not for enterprise system. Infrastructure must be reviewable, reproducible, control, log, That is why we need a better architecture. Architecture goal. So what are our goals? We need 6 key components. First, multiple account strategy. Net, remote backend, net cross-account IAM, net CI/CD pipeline, net plan and apply separations, net policy-based governances. Each of these reduce risk, multi-account user isolation, remote backend protect state, cross-account IAM control access, CI/CD remove manual execution, plan apply separation, ensure determinism, policies at code, enforce complaints automatically. This architecture is built around 3 principles: isolation, control, automation. When we design infrastructure this way, we move from developer managed infrastructure to enterprise grade infrastructure platform. AWS organization. Now let's talk about multi-account architecture. We use AWS organization. We create a management account, a dev account, a production account, while separate accounts. Because accounts are the strongest security boundary in AWS. If something goes wrong in that, it should not affect production. This is what we call reducing the blast radius. Blast radius means how much damage can one mistake cause. With a separate account, building is separated, IAM is isolated, policies are independent, resources cannot miss accidentally. Production must be isolated from development. This is a standard practice in enterprise cloud environments. Workspace are not enough. Folders are not enough. Accounts are the correct boundary. Cross-Account IAM rule. Now, how the GitHub action access AWS? We do not use access keys. Access keys are long-lived credentials. They are risky. Instead, we use OIDC. OIDC allows GitHub to authenticate to AWS using short-lived token. The flaw is GitHub actions assume roles in a management account, then assume roles in that or product account. This is called cross-account role assumption. The benefit: no store AWS secret, temporary credentials, strong trust relationships, full audit login in AWS Cloud Trail. This is modern, secure authentication. It follows the principle of less privilege, and it removes one of the biggest security risks, like access keys. Terraform backend architecture. Now let's talk about Terraform state. Terraform state is critical. It records what infrastructure exists. If 2 developers run apply at the same time, the state can become corrupted. That is dangerous. So restore state remotely in S3. Benefit: centralized storage, team collaboration, no local state files, encrypt storage, and we enable state locking. State locking prevents 2 apply at the same time. Without locking, we risk overwriting state. In enterprise system, states must be shared, protected, locked, encrypted. Remote Backend is not optional, it's mandatory. CI/CD workflow. Now we connect everything using CI/CD. Here is the flow. Developer create a pull request. GitHub action run a Terraform plan. The plan is reviewed only after approval and merge to main does Terraform apply. Important principle. Pull request plan only. Main branch apply. Production should never be applied from a pull request. This ensures code review, visibility of change, control deployment. We remove execution from laptop into an automated control system. This is the foundation of infrastructure as code governance. Plan and apply separation. This is a professional technique many teams skip. Instead of running Terraform plan and Terraform apply, we run Terraform plan out equal plan point the app plan. Then we apply exactly that's why because it's guarantee determinism. The plan review is exactly the plan apply. Without this, trip can happen. Maybe the state trend between plan and apply. Maybe someone modify code. This separation gives reproducibility, auditability, confidence. This is senior level Terraform practices. Workspace and environment. Many people think Terraform Workspace are enough. Workspace separate the state, but they do not separate the AWS account. There is no IAM boundary, no built-in separation, no security isolation. Workspace are good for simple scenarios, but they do not replace multi-account architecture. Multi-account architecture. Enterprise systems require account-level isolation. Security boundaries must exist at the AWS account level. That is why multi-account strategy is the standard. Policy as code. Now we add the governances. Policies as code means we write security rules as code using tools like OPA, Sentinel. For example, block public S3 bucket require specific stat on EC2, prevent deployment outside approved regions. Instead of manual security review, the pipeline enforces rules automatically. If policy fails, deployment stops. This is just set up in action. Security is not an effective, it is integrated into automation. Infrastructure must comply before it is created. Finally, architecture. Let's summarize everything. Our final architecture includes AWS organization, net multi-account strategy, net OIDC authentication, net cross-account IAM roles, net S3 remote backend, net GitHub actions pipeline, net plan apply separation, and net policy as code governance. Each layer adds control, each layer reduce it. Together we create secure, scalable, auditable, enterprise-grade infrastructure automation. This is no longer running Terraform. This is building a cloud platform. This is thinking like a cloud architect. Our projects have 4 flows like this. Now we move to the flow number 1. Let's start with the flow number 1, the bootstrap phase. Before we automate anything, we must build the foundation. This step is done manually from a developer's local machines. We run Terraform apply in the AWS management account, but this is not application infrastructure. This is automation infrastructure. We create an S3 bucket for remote Terraform stage. Next, a GitHub action IAM role using OIDC. Next, a Terraform deployment role for that and production account. This setup enables secure authentication, state storage, and cross-account access. Flow number 1 happens only once. After this, we stop applying Terraform manually. Everything moves into CI/CD. Now we move to the flow number 2, the validation phase. A developer pushes code to a future branch and open a pull request. This automatically triggers GitHub action. The pipeline authenticates to AWS using OIDC and run Terraform init and run Terraform plan and execute OPA policy checks. Finally, the plan output is passed as a command in the pull request. Important, nothing is applied here. This flow ensures peer review, transparency, and policy enforcement before any infrastructure change happen. It's a separate validation from execution, which is critical for safety. Flow number 3. Once the pull request is approved and merged into the main branch, flow number 3 begins. GitHub action is triggered again, but this time is perform deployment. The pipeline authenticate using OIDC, then run Terraform init, then create a plan file with a Terraform plan output equal tf plan, then apply as exactly that plan file, then run policy check, then assume the correct AWS account role. Only the main branch can trigger apply. This guarantee that only review and approve changes are deployed. Flow number 3 ensure control, deterministic, and auditable infrastructure updates. Finally, flow number 4 handle destruction, the most sensitive action. Destroy is never automated. Developer must go to GitHub actions, manually run the workflow, select destroy and type destroy as a confirmation. Then the pipeline, the authenticate using OIDC, then run Terraform destroy, then execute policy checks, then assume the target role and destroy infrastructure. This ensure deletion is intentional control and lock. Finally, together, these four flows create a complete infrastructure lifecycle, bootstraps the foundation, validate change safely, apply approve update, destroy infrastructure in a controlled way. This approach transforms Terraform from a local tool into a secure enterprise-grade automation platform. Now move to demo app session. For the structure, we have to add this policy to the current AWS account. Run bootstrap.